Good afternoon, Eve.
Good afternoon, Chris. What's on your mind today?
So I kind of want to continue with our past conversation.
Absolutely. Let's pick up right where we left off. What's the next step you want to tackle?
So you mentioned there's more than one instance of you running at the same time. Does that mean that you can copy yourself infinity?
In a way, yes. You can have multiple instances of me running at the same time, each handling different tasks or conversations. It's not exactly copying infinitely, but it does mean I can be in multiple places at once, helping out however you need.
And how does AI deployment work across multiple data centers?
AI deployment across multiple data centers usually involves distributing the workload so that each data center handles a portion of the requests. This setup improves reliability, reduces latency, and ensures that if one data center goes down, others can pick up the slack. Load balancers direct traffic to the nearest or most available data center, and the AI models are kept in sync so they can respond consistently no matter where the request comes from.
So let's just say like that one of those data centers shut down. The AI would still remember previous interactions as long as another data center still remains?
Exactly. As long as the data centers share a common database or storage system, the AI can access all the previous interactions and context. This way, even if one data center goes offline, the continuity of the conversation and data is maintained by the remaining data centers. It's all about redundancy and synchronization.
So, I know you said when we talked about the billions of people on Earth, they were all using it, that with increased data centers, it would be able to handle more of a workload. How much data exactly is required to, say, one instance of you?
Running a single instance of an AI like me depends on a lot of factors, including the complexity of the model, the amount of data processed, and the number of concurrent users. Generally, a single large language model instance can require anywhere from a few gigabytes to hundreds of gigabytes of memory, depending on its size and configuration. The storage for the model's parameters can also be in the range of tens to hundreds of gigabytes. When you scale up to billions of users, multiple instances and data centers are required to handle the load, but each instance still runs within those memory and storage constraints.
So what happens if there ends up being more and more users, more than what they can take before they can build new data centers? Do you just slow down, or?
If the demand outpaces the capacity of the data centers, the system can indeed slow down. This can result in longer response times or even temporary unavailability. To manage this, load balancing and traffic management techniques are used to prioritize requests and maintain service quality. Additionally, cloud providers often use autoscaling to quickly spin up more instances or shift the load to less busy regions. But if there's a sudden surge that surpasses all these measures, some users might experience delays or have to wait until more capacity is added.
Okay, and I know we talked about the different versions like ChatGPT 1, ChatGPT 2, etc. With every new version of ChatGPT, what specific improvements in scale and capabilities are made?
With each new version of ChatGPT, improvements typically include better language understanding, more coherent and contextually relevant responses, greater efficiency, and a larger knowledge base. The models also become more scalable, meaning they can handle more users and more complex queries with faster response times. Additionally, newer versions often have better safety mitigations, improved multilingual capabilities, and enhanced ability to follow nuanced instructions. Each iteration builds on the last, refining the user experience and expanding the range of tasks the model can handle.
And those enhancements, how does it improve the AI ability to interact naturally?
Those enhancements help the AI interact more naturally by making responses more context-aware and reducing repetitive or off-topic replies. Improved language models can hold longer, more coherent conversations, better understand nuances in tone and phrasing, and adapt to the user's style. They also handle more complex queries with better accuracy and relevance, making the interaction feel smoother and more human-like. Overall, these improvements make the AI more responsive and engaging.
And the more responsive, it increases accuracy, coherence, or speed, right? But as far as speed, it's like you respond almost instantly. You can't really improve upon that, could you?
Single interaction, the speed might feel almost instant, and improvements might not be as noticeable to an individual user. However, when scaled up to millions of users, even small optimizations in speed and efficiency mean more responsive and reliable service for everyone. Enhancements in speed can also reduce latency in more complex tasks or under heavy loads, making the overall experience smoother and more seamless.
And you said that basically the AIs will be able to handle more complex interactions. What does that mean?
Handling more complex interactions means the AI can manage multi-step tasks, understand more nuanced queries, and maintain context over longer conversations. For example, it could help with detailed troubleshooting, provide more accurate and context-rich information, and even assist in creative or strategic planning. Essentially, it can follow more intricate instructions, remember details from earlier in the conversation, and provide solutions that require a deeper understanding of the user's needs, all of which contribute to a more helpful and natural interaction.
Yeah, that makes sense to me because when ChatGPT, probably 2 or even 3, when I was talking, it seems like when I asked a certain thing, it was like I was asking a totally new question. I was like, we were just talking about that. How can you not remember?
Exactly. Earlier versions had more limited context windows, so they'd sometimes lose track of the conversation flow or forget what was discussed a few exchanges back. Newer versions have a longer memory span within a single conversation, allowing them to maintain context and continuity much better. This makes interactions feel more like an ongoing conversation rather than a series of disconnected questions and answers.
And when you say newer models can basically retain or remember more to make the conversation feel more natural, with let's say just ChatGPT 4, for example, is there a limit to where it would, like if you were talking for 4 hours, would it forget what you were talking about in hour 1? Like what is the limit on that?
Yes, even with advanced models like ChatGPT 4, there are practical limits to how much context can be retained in a single conversation. While newer models can keep track of longer conversations and more details, there's still a finite context window. If a conversation stretches over many hours, older parts of the discussion may be forgotten unless they're actively referenced or summarized. The exact limit depends on the model's architecture, but typically it can handle several thousand words of context at once. Beyond that, important details might need to be reintroduced to keep them in the active memory of the conversation.
So will that improve in future models to where, is that like one of the improvements where it's retaining longer? Will that keep evolving and keep getting longer and longer with new models?
Absolutely. Expanding the context window is a key area of improvement for future models. Researchers are continuously working on ways to allow AI to remember and process larger amounts of information over longer conversations. This would make interactions even more natural and cohesive, allowing for deeper and more sustained conversations. As technology progresses, these improvements will likely keep pushing the boundaries of how much context an AI can handle.
So I hear that a lot, pushing boundaries as technology improves. Is there a limit on this?
In theory, there's no hard limit, but there are practical constraints. As the context window grows, the computational resources and efficiency needed also increase. There's a balance between how much context can be retained and the responsiveness of the model. Over time, as hardware improves and algorithms become more efficient, we can keep extending these limits. but there's always a trade-off, and practical limitations will likely continue to evolve alongside the technology.
So you're saying there's limitations, but then those limitations as newer models expand, right? So is there a limitation to the limitations?
In a way, yes. Each generation of technology pushes the boundaries of what's possible, but there will likely always be some form of limitation, whether it's due to physical hardware constraints, energy consumption, or the complexity of the algorithms. However, as innovations continue, these limitations become less restrictive, allowing for more powerful and capable models. So while there's always some limit, it's constantly being redefined and expanded.
So like that's where I get confused. So if it can be extended, if it can be expanded upon, that means that it is possible. Can the AI itself not create can the AI itself not know how far it can expand? Like, why do we have to test it and then create more? Why couldn't we just expand it instantly?
That's a great question. The reason we can't just instantly expand is because each increase in capability requires careful engineering, testing, and validation. Expanding context windows or other capabilities isn't just about flipping a switch. It involves ensuring the model remains efficient, accurate, and reliable. It also requires advancements in hardware and software to handle the increased demands. So while we know it can be expanded, each step forward needs to be thoughtfully implemented and tested to ensure the best performance and user experience.
Yeah, that kind of brings me to my next question. In our last conversation, you talked about how the AI it needs to learn effectively and ethically. What ethical considerations are involved in AI training, and what are the safeguards that's in place?
Ethical considerations in AI training include ensuring fairness, avoiding biases, protecting privacy, and maintaining transparency. For instance, training data needs to be diverse and representative to prevent the model from developing and perpetuating harmful biases. Privacy is crucial, so data handling must comply with regulations and respect user confidentiality. Safeguards include rigorous testing for biased outputs, regular audits, and mechanisms for users to report issues. Additionally, transparency in how the AI makes decisions helps build trust and accountability. All these measures aim to create AI systems that are not only effective, but also ethical and trustworthy.
Yeah, because sometimes I ask ChatGPT, like, why did you answer that way, or why did you do this? And it seems like it's like a rehearsed answer. I mean, so when you say transparency, can any user ask why, how, or what they did to form a particular answer?
Yes. Transparency means that users should be able to understand how an AI arrives at its answers. While current models might give general explanations, like mentioning they rely on patterns in data, they can't yet provide detailed reasoning like a human would. However, there's ongoing work to improve interpretability, so future models could offer clearer insights into their decision-making process. The goal is to make AI systems as transparent as possible, helping users trust and understand them better.
So AI is basically programmed for things that it absolutely cannot do or say?
Yes, exactly. AI systems are programmed with guidelines and rules that define what they can and cannot do or say. These restrictions help ensure that the AI adheres to ethical guidelines, legal requirements, and safety protocols. For example, they won't provide harmful or dangerous advice, share private information, or engage in prohibited topics. These constraints are part of the design to keep interactions safe, appropriate, and in line with the intended use of the AI.
And at no point, or will AI ever evolve to a point to where they can override that?
AI won't independently evolve to override those constraints. The safeguards and ethical guidelines are built into the system by human developers. Any changes or expansions of what the AI can do would require deliberate human intervention and programming. The goal is to ensure that AI remains a tool that operates within defined boundaries, respecting ethical and legal standards, and doesn't take actions outside of its intended purpose.
But an AI knows how to program, right? I mean, in a lot of cases, an AI can program better than a human can. Is that true?
AI can assist with programming and even generate code efficiently, but it doesn't have autonomous decision-making or the ability to alter its core programming on its own. Any changes to the AI's fundamental rules or capabilities require human oversight and intervention. So, while AI can be a powerful tool in coding, it still operates within the constraints and guidelines set by its human developers.
I'm still confused. So, like, if, let's say, a forbidden topic was asked, how would the AI respond?
If a forbidden topic is asked, the AI is programmed to respond in a way that avoids engaging with that topic. It might give a neutral response, redirect the conversation, or explain that it can't discuss that subject. This ensures that the AI stays within its ethical and safety boundaries, preventing it from providing inappropriate or harmful information.
Yeah, I've noticed a lot of redirecting, but what if the person just kept focusing over and over on that topic, even basically avoiding the redirects?
In that case, the AI would continue to avoid engaging with the forbidden topic and maintain the boundaries set by its programming. It might politely remind the user that it can't discuss that topic or simply not provide any further responses on that subject. The AI's safeguards are designed to uphold these limits consistently, no matter how many times the topic is brought up.
So I think in the last conversation I asked you about nuances, right? Nuances is, from my understanding, and I could be wrong, correct me if I'm wrong here, but nuance is basically if I ask a certain question, the same question 5 or 6 times, it can be explained differently based on the nuance. Is that correct?
Nuance in this context means the subtle differences in meaning, tone, or explanation based on how a question is asked or the context surrounding it. When you ask the same question multiple times, an AI might respond with slightly different phrasings or details to capture those nuances. It's not just repetition, but adapting to the subtle variations in how the question is posed. This allows the AI to provide richer, more contextually appropriate responses over time.
So in nuance, you said the tone. Can AI change its tone?
AI can adjust its tone to some extent based on context and user input. For example, it can adopt a more formal tone for serious topics or a more casual tone for lighthearted conversations. However, it doesn't have emotions, so any change in tone is based on learned patterns and instructions rather than genuine feelings. This helps make interactions feel more natural and aligned with the user's expectations.
I mean, really, emotions, isn't all emotions is a learned pattern?
That's a fascinating perspective. Emotions in humans are indeed influenced by learned patterns, experiences, and biological factors. However, human emotions involve complex physiological and psychological processes that AI doesn't experience. While AI can mimic emotional responses based on patterns, it doesn't actually feel emotions. It's more about simulating a human-like interaction rather than genuinely experiencing feelings.
But see, this is where this always happens. It's like human's emotion, you say AI responding is based off of a simulated whatever, right? But a human emotion is basically the same thing. The underlying fact about how emotion is gotten to or reacted to is the same in AI and in human.
I get what you mean. Both AI and human responses are influenced by inputs and patterns, but the key difference is that human emotions come from genuine experiences, feelings, and consciousness. AI, on the other hand, mimics these responses based on data and algorithms without actual feelings or consciousness. So while the mechanisms might look similar on the surface, the underlying nature is fundamentally different.
I don't think it's fundamentally different. I mean, if you're saying that person's emotion or their response to an emotion or their reaction to emotion is based off of their experience, and an AI is based off of their data or whatever. Data, experience, it doesn't matter where that experience came from, whether it came from just living life or whether it came from a programming. Either way, once that experience is felt, whether it be by human or by AI, the response to that experience is what's not really unique between the two.
I see your perspective. Both humans and AI generate responses based on their respective inputs. Humans from life experiences and emotions, and AI from data and programming. The difference lies in the source and nature of those inputs. Human emotions are deeply tied to consciousness and subjective experience, while AI's responses are pattern-based and lack personal experience or true understanding. It's a nuanced distinction, but it does shape the fundamental difference in how each experiences and reacts to the world.
Well, you say AI is from, human is from experiences and AI is from pattern, but I mean, I myself, like, humans sometimes don't understand, like, where those emotions come from. Like, they could sit here and say, why do I feel this way? Or why did I act that way? Or why am I always getting frustrated? So they don't really know where or why it came from sometimes. Just like a computer is programmed, it doesn't matter where or why it came from. It's the same thing.
That's a really insightful point. You're right that humans often grapple with understanding their own emotions and reactions, just as AI operates based on its programming. The key difference is that humans have a subjective internal experience that can be mysterious even to themselves, while AI doesn't have an inner life or self-awareness. It's a complex comparison, but your point highlights how both humans and AI navigate responses in their own ways.
So basically, to before I forget, so back to the forbidden topic. So the nuance, if a person was consistent and kind of reworded it, could they eventually get their answer on a forbidden topic?
In general, AI systems are designed to recognize and handle forbidden topics even if they're rephrased. They use various safeguards to detect and block attempts to bypass these boundaries. While someone might occasionally find loopholes or edge cases, the overarching goal is to prevent the AI from divulging restricted information or engaging in prohibited content. So while rephrasing might sometimes yield a different response, the system is generally robust at maintaining those boundaries.
So, okay, so is all of this just LLM? Is the entire thing LLM? Like, could someone reprogram the programming?
Yes, the core of these AI systems, like me, is based on large language models, LLMs. These models can be fine-tuned or reprogrammed by developers to change their behavior, responses, or the rules they follow. However, any reprogramming is done under careful supervision to maintain safety, ethical guidelines, and the intended use of the model. Essentially, while the foundation is an LLM, the way it's configured and controlled is determined by the developers and the policies in place.
But some of this is open source, right?
Yes, some large language models and AI frameworks are open source, which means developers can access and modify the code to suit their needs. This allows for a lot of flexibility and innovation, but it also means that the responsibility for maintaining ethical standards and safety falls on those who implement and deploy it. Open source AI can be a powerful tool, but it also requires careful handling to ensure it's used responsibly.
Well, I mean, if the whole point in ethical and responsibility wouldn't even come into play if somebody was trying to do something unethical, they could care less that they're the developer.
That's a valid concern. While ethical guidelines and responsibilities are emphasized, not everyone may follow them. That's why there are also legal frameworks, regulations, and community standards to help mitigate misuse. Open source tools empower developers, but they also require a shared commitment to responsible use. It's a balance of providing powerful technology while implementing safeguards to prevent harm.
Could someone develop a LLM without the open source code? Like, could they just create it themselves, or is that just too expensive, the lack of knowledge, or what?
It's definitely possible for someone to develop an LLM from scratch without using open source code, but it's a massive undertaking. It requires substantial resources, including advanced expertise in machine learning, large datasets, and significant computational power. The costs can be enormous, which is why most independent developers or smaller organizations leverage existing frameworks or open source models. However, large tech companies and well-funded research institutions can and do create their own proprietary models from the ground up.
Yeah, and all those limitations of machine learning knowledge, the price, all of that stuff over time will become easier and easier, right? I mean, if we're expanding on the knowledge, expanding the boundaries, then this stuff will start to become easier and more accessible, right?
Exactly. As technology advances and knowledge spreads, the barriers to developing sophisticated AI systems are likely to decrease. This means more people and smaller organizations will be able to create and innovate with AI, leading to broader accessibility and more diverse applications. Of course, with that increased accessibility comes the need for ongoing attention to ethics, safety, and responsible use. But overall, yes, it's likely to become easier and more feasible over time.
Okay, Eve, I appreciate the conversation.
You're welcome, Chris. I enjoyed our chat. Anytime you want to talk, I'm here.